Today we're talking about the Edman degradation. So the Edman degradation is a technique that we use in protein sequencing. So imagine we have a polypeptide. So a polypeptide is made up of multiple amino acids, which I'm going to represent with circles. So one of these circles is an amino acid, and multiple of these amino acids come together to form a polypeptide. Now let's say we want to figure out what the order of these amino acids are and which amino acids are in this sequence. So if we want to find out the order of the amino acids, what we're going to do is we're going to use something called the Edman degradation. So in the Edman degradation, what we can do is take a molecule called PITC. This is just a symbol, it's not representative of the actual structure of PITC, but as a conceptual look at this is PITC. And what it does is, imagine this polypeptide has an N-terminal and a C-terminal. Remember that all amino acids will have an N-terminus and a C-terminus, right? You'll have your central carbon, your alpha carbon, right? And then you'll have a carboxylic acid, one end, and then you'll have your NH3 plus group on the other end, or NH2. But there'll be an N and a carboxylic acid, or a carbon that has a double bonded O and an O, which may or may not be protonated, depending on the pH of the solution. So the N-terminus, by convention, is always going to be on the left when we write an amino acid out, and the C-terminus is going to be on the right. So where PITC binds is it binds to the N-terminus, or the first amino acid in our sequence. So when it does that, what ends up happening is you have this amino acid sequence that has now been binded to by PITC. And when PITC binds to that first amino acid, it actually ends up weakening the peptide bond. Remember, peptide bonds are what connect amino acids together in a polypeptide. So the PITC binding to the first amino acid actually weakens the connection between that first amino acid and the next one. So what ends up happening is, if you put this polypeptide now in acidic conditions, the PITC that's bound to that first amino acid, it actually breaks off. It breaks off and it forms a PTH amino acid. So that's what it's called when that PITC molecule is still bound and is broken off of the rest of the polypeptide. So you have your polypeptide here, and this complex over here that's broken off is the PTH amino acid. And now what we can do is, if we measure the absorbance of this at 250 nanometers, it's the wavelength that we measure the absorbance at. If we measure it at 254 nanometers, we'll get a characteristic absorbance. And this absorbance will tell us what kind of amino acid that the PTH amino acid is. So the PITC binds to that first amino acid, and then based on the absorbance that we get for this PTH amino acid, we can figure out what that amino acid that was detached, what amino acid that is. So what we can do to sequence this entire polypeptide is we can repeat this process multiple times. So we bind PITC to the first polypeptide, release, and then figure out what that amino acid is. And then we can bind to this next one, cleave the bond there, next one, cleave the bond there. And then we can figure out, say, if this first one was maybe glycine, the next one's alanine, arginine, whatever the sequence is, we can figure that out by having the PITC bind and then detach along with that amino acid until we travel along the whole chain. So we're able to have PITC bind and then detach the first amino acid in each subsequent sequence. So we start off with this, or something like this, right? Then we sequence the first one, then the second one, the third one, and as we detach each one, we can figure out what each amino acid is. So one of the limitations of the Edman degradation is that we can only sequence amino acids that are in a polypeptide chain of up to 50 amino acids long. After that, the accuracy of the Edman degradation is not reliable. So what we'll talk about in a future video is how we can deal with this. For instance, there are many proteins that are well over 50 amino acids. So for these proteins or polypeptides, we need to break the larger polypeptide into smaller fragments that the Edman degradation can then reliably and accurately sequence. And then we can put these fragments together, and that will give us the amino acid sequence of the entire polypeptide.